Hello everyone, this is Harry Gill, and in this video we are going to look into serialization and deserialization. Before we jump into the programming, let's first see what serialization is theoretically. So let's say you have a Java program running, which essentially means the Java virtual machine be running on your system, and you have created few objects. Let's say one of that object name is person, and that person will have some of the properties, and let's say you have set the values of these properties as well. At this stage, if you stop your program and then rerun your program, to get to this stage, you will have to go through the same steps again, which means you have to create a person object, you have to set the name as John and also age as 20 to get to this stage. Let's say we want to try to avoid that. When we stop the program and after some time when we rerun the program, we want the memory state to be in this state. So we want to have a person object already created and the properties needs to be set what we have on the screen. To do this, what we need to do is we need to save the state of the memory into the hard disk. And this process of saving the object into hard disk is called serialization. And deserialization is a reverse of serialization, which means the program will read the content of the file wherever you have saved in the hard disk into memory and create a snapshot. Now, because the program is interacting with the hard disk and the state is actually saved onto a file on the hard disk, this is the reason why serialization and deserialization is a part of file IO topic. In the previous few videos, we have already seen these classes. In this particular video, we are going to read about object input stream and object output stream. Now let's jump into the IntelliJ and look at the program. I'm going to create a class and I'll name the class as Serialization Example. In the main method here, I'm going to serialize another class. And let me just create this class and I will name it as person. It can be really any class. And I'm going to create few attributes of this person. In our main class, I've created a person. Let's print that person out. So this is where our toString method comes handy. And now I'm going to serialize this object. At this stage, we have the person object into the heap and the person object has a name set and also an age. What I'm going to do, I'm going to save that person object onto the hard disk. I will use the try with resources syntax. And to save the person object, we will need object output stream. And object output stream is a high level IO class. We will need a low level class. And in this case, we will need file output stream. And in here, we will give the name of the file where we want to store this object. This name can be anything, it doesn't have to be person. Now to save the person into the actual hard drive, so we will use object output stream and the write object method on that class, and we will simply pass the reference of the class. Now this program will fail, but I'm going to run and show you what that error will look like. So this program fails, complaining with no serializable exception, and it gives the name of the class. What this means is, it's actually a very important concept. If we are serializing any class, that particular class, in this case person, needs to implement an interface called serializable. Serializable interface is a marker interface, which means it doesn't have any method. So we are not implementing anything here in the person class, But this method simply tells the Java that the person class is serializable. And now I'm going to save it and let's run the program again. And there you go. So we have nicely printed it and we have saved it. So let's exit the presentation mode. And you see we have now created a person class. So I will double click this, open matching file in IntelliJ, and let's select text. So you will not be able to see the content of the file. And the reason is this file is a binary file. In the previous videos, we have seen two types of streams, byte stream and character stream. When we save an object onto the hard disk, we save it in a byte format. So that is the reason the object input stream and object output stream, both of them are the byte streams rather than the character streams. So you don't have to really worry what the content of the file, because it will be rarely you will actually look at the content. So I just show you for an example. Also, one thing I wanted to mention was that in this particular case, I have simply used the file output stream as the constructor of object output stream. What we should also do is have another layer and use buffered output stream. And in the previous video, we have already seen the benefits of using buffered. It's because if we are doing the serialization of lots of classes, then to gain performance, we will use buffered output stream. So this is an example of serialization. Now let me create another example, and now I will create a deserialization class. I'm going to name it as deserialization example. So to deserialize, we will have to use object input stream. We will use buffered input stream, and also we will chain it with file input stream. And this name that we give here, it needs to match the name we gave in the previous example. And the way we will read this is read object. So this read object will return the type of object. So we will need to cast it because we know it's a person type. So we simply cast it. And once we are done deserializing, now let's print it. I'll have to move this within because I have only declared it here. So let's run the program. And there you go. So as you see in this program, we haven't really created any object ourselves. We haven't set name and we haven't set age, but when we deserialize, we actually get the state nicely. So this is effectively what serialization and deserialization is at a very high level. There are a few more concepts that I'm going to discuss which comes in play when we serialize or deserialize. The very first concept is that you will see a term called transient. So transient effectively means that whenever this person object is now serialized, whatever attributes are marked as transient, they will not be saved to the file. So now let's run this program. And we have saved this file here, and now let's deserialize it. So you see now the age is set as 0, not 20. The reason is because when we serialized it, because of the transient keyword, the value of age is not stored into the file. And of course, because it's not stored, it's not read as well. The reason why it's 0 is because when it's deserializing, then all the transient attributes, they actually take a default value of according to their type. For int, which is 0. If it would have been a string, the value would have been null. Now, another concept. Let's say this person has a car. I'm going to create another class called car. Let me also create a toString. And person has a car. So I'm going to recreate both of these methods again. Now in this, while serializing, we will have to pass in car as well. So new car, and let's say Chevy. And I'm going to run the program which will serialize it. So we got an exception saying not serializable exception for car. Now, the reason why we got this is even though person is serializable, when it tries to serialize its attributes, all the attributes that it has, they need to be serializable as well. The reason why we did not get the same exception for string is if you go into the string, you will see that string is serializable. That's why we didn't see this error before. To fix this issue, what we need to do is we simply extend serializable on car. Now I'll run the program again. And now the program has run nicely, and it has also saved the car of the person. Now going back to deserialization, I'm going to run it again, and it nicely reads the car as well. And we didn't have to do any changes. Now the one final concept that I want to explain is that whenever a deserialization happens, the Java doesn't call the constructor or even the initialization blocks. So all those settings are done by reflections internally. Just to show you that example, so I'm going to put a system out statement. So just a simple system out statement so that we can know whether program came here or not. Similarly, in the initialization block. Now we have simply printed the initialization of person in the initialization block. Now let's go to the serialization example. Let's run this. And you see we have initialization of the person. So the initialization block got called because we did a new here. A constructor of the person got printed because that's what we have in that. And then this is our previous log line. Now the interesting thing is, now when we are doing the deserialization, none of that happens. So effectively the creation of the object doesn't go through the exact same life cycle as the normal creation would go if we do a new. So these properties are set by reflection directly by Java. All this deserialization happens in the background. You don't need to be worried about how exactly it happens as long as you know the concept, what the concept is, you know, transient, and you need to know that we need serializable interface needs to be implemented. That's pretty much, you're good to go with the serialization. Now that brings us to the end of the session. If you like the video, hit the like button and subscribe for upcoming videos. Thank you so much.